Jai Hind everyone, I am Mili Srivastava from IT department, Ajay, Garg Engineering College, and today I am going to discuss about disk scheduling algorithm. So what is disk scheduling algorithms in operating system, why it is needed and required, and what are the main important role of disk scheduling algorithm in operating system. So first of all, what is disk scheduling algorithm and why it is needed? In case of disk scheduling algorithms basically disk scheduling in operating system is the method which is used to decide the order in which disk input output management or request or whatever we required are serviced. And since disk access is relatively slow, when we needed some different types of disks like magnetic disks, optical disks, or whatever we required, and there are some access which is relatively slow compared to CPU speed, efficient scheduling improves overall service performance. So with the help of disk scheduling algorithms, we access or we can move in or fast the scheduling algorithms or schedule whatever the performance system. Basically, we can say that system performance, we can increase or enhance system performance with the help of disk scheduling algorithm. So why disk scheduling is needed, why it is required, and what are the role of disk scheduling algorithms in operating system. So basically there are some very much useful and important role of disk scheduling algorithm in operating system, that is multiple processors request disk access simultaneously. With the help of disk scheduling algorithm, we can control or improve the access management of data which is handled by CPU, and there are so many processes and requests which is required CPU for time to time and analysis recording according to the CPU scheduling algorithms. And with the help of disk scheduling algorithms, we can improve the efficiency of CPU or system. So disk head movement which is also known as seek time is costly. So with the help of these disk scheduling algorithms, we can minimize the seek time or disk head movements. Now there are some basic goals of disk scheduling algorithms, that is minimum seek times, reduced latency, and maximum throughput. Now in case of magnetic disks in computer architecture, when we talk about different disks, now first of all, we can enhance or access magnetic disks. So magnetic disk is a storage device. Basically, we know that very well what are the magnetic storage. Magnetic disks is the storage devices in which the data that is used to write, rewrite, and access data. Basically, magnetic disk is used for read, rewrite, and access data. It is uses the magnetization process. With the help of magnetization process, we can use our storage devices and rewrite or access any file whatever we required. Now what are the architecture of magnetic disks? The entries disk is divided into platters. We see this in example. So basically magnetic disks, a particular disk is divided into this is divided into tracks. There are so many tracks, this track, and this track. There are two or more tracks which is divided the disks into different tracks, and further we divided these tracks into sectors. We see that in this diagram that we divided tracks into sectors, and with the help of these magnetic disks, we manage these magnetic disks in the cylindrical form, and this complete structure is known as the cylinder. This is a cylinder of these magnetic disks, and basically there are some important terms in magnetic disks, like there exists a mechanical arm called read-write head. It is used to read and write to the disk. Basically, read-write head this plays very important role in form of disk scheduling algorithms, and it is basically used to form whatever we required data for enhance the efficiency of CPU. So read write to the disk, and head has to reach at a particular track and then wait for the rotation of the platter, which is divided into sectors or tracks. Now the rotation causes the required sectors of the track to come under the head, and with the help of these each platter has two surfaces, top and bottom, and both the surfaces are used to store the data. We used basically there are two surfaces in each and every platter. So with the help of these two platters, we stored that data both in both of the form, like top and bottom, and both the surfaces basically used for data storage. Each surface has its own read-write head. Now it's the complete structure of magnetic disk in computer architecture. This is a hardware requirement. So I already told that this is tracks, and tracks further divided into sectors, and with the help of two or more magnetic disks, we create with the help of cylinder, we create a simple magnetic disk storage form, and by which we store that data. It is called or known as a spindle. Spindle is the middle part of this magnetic disk drive, which is used for data storage and compensatory. Now there are some we can say that there are some important terms by which we solve the problems of disk scheduling algorithm, disk scheduling with the help of different disk scheduling algorithms, like first come first serve, shortest time seek first, shortest seek time first, and scan, C scan, look, and C look. There are some different algorithms by which we schedule disk for better utilization of CPU. So what are the main important terms? First is seek time. What is seek time? Basically time to move disk head to the required tag. This is known as seek time, and it is by which we can analyze the time factor of what algorithm is used or required or useful or beneficial or making in terms of efficient. So seek time is required for basically time to move disk head to the required track. Now next is rotational latency. What is rotational latency? Basically time waiting for the desired sector. What now these are some important terms like seek time, rotational latency, data transfer rate, controller overhead, and queuing delayed. So in case of seek time, the time taken by the read-write head to reach the desired track is called a seek time. So basically in seek time basically we calculate seek time with the help of time to move disk head to required track. Now next is rotational latency. What is rotational latency? The time taken by the desired sector to come under the read-write head is called the rotational latency. With the help of rotational latency, we can calculate the actual waiting time for the desired sector. What are the actual waiting time any of the sector required for the next step. Now next is data transfer rate, or we can also say that this is transfer time. So what time and what amount of time is taken in time to read write data. So whatever the time transfer time, basically time to read write data, and the time of data that passes under the read write head is a given amount of time is called a data transfer rate. Now the time taken to transfer the data is also called the transfer time, which is by which we can calculate the overall time, overall data transfer rate whenever we need it. Now what is disk scheduling and why it is needed? So first of all, there are so many algorithms. I already told that there are 6 algorithms which is generated for disk scheduling, by which we can enhance or maximize the CPU utilization or disk utilization. That is first come first serve disk scheduling algorithm, by which in case of first come first serve FCFS, which is also known as FCFS disk scheduling algorithms, basically as the name suggests, this algorithms entertains requests in the order they arrive in the disk queue, or we can say that requests are served in arrived order, like first come first serve. First whenever whatever in CPU scheduling algorithm, I already explained what are any process which enters first in the ready queue, and it passes for only that process. Whenever that process completed its execution, after that the next process come into the ready queue or running queue. So in disk scheduling first come first serve behaves like consider this is a numerical problem of disk scheduling algorithm. Like, consider a disk queue with request for input output to blocks on cylinders 98. This is a queue given in the question, and the FCFS scheduling algorithm is used by with the help of FCFS scheduling algorithms, and it is also given that the head is initially at the cylinder number 53. So first of all, in this data set, we initialize this line into from 0 to 199. 0 is the initial point and 199 is the last, or we can say that end point. And it is given that our head initially at at the position of 53, and according, like in case of FCFS scheduling algorithms, there is a string which is given already given. Now head starts starting point of head's movement is 53, and after that head goes to 53 to 98, which is given in the string, or which is already given in the string, like head moves 53 to 98, and after 98 there is 183, so head moves 98 to 183, and after that 83 to 41, so head further moves 183 to 0.41, and after that 41 to 122, so head moves from 41 to 122. So there are head movements according to the FCFS, first come first serve basis, which is already given in string. So after that 124, so next head moves 122 to 14, 122 to 14, and after 14 head moves 14 from 14 to 124, and after 124 head moves 65, and after 65 it moves from to 67. So this is the basic architecture or structure of FCFS algorithm, and how we solve it. Now we simply calculate the distance in between the head movement. So first is, and it will never be negative. So 98 minus 53, 183 minus 98, and 183 minus 41, like simple 98 minus 53, 183 minus 98, and 183 minus 41, and 122 minus 41, and 122 minus 14, and after that 124 minus 14. Now 124 minus 65. After that 67. Last step, last movement is 67 minus 65. So when we calculate this these head movements in positive forms, then answer will be 632 cylinders. So this is the answer of first come first serve algorithm. Now next is SSTF disk scheduling algorithm, which is also known as shortest seek time first. In shortest seek time first, the time this algorithm basically services that the request next which requires last number of the head movement, or we say that in forms of it basically selects request closest to the current head position. It also works on the basis of shortest job first, which we discussed in CPU scheduling algorithm. So basically SSTF works on the select request closest to the current head position, closest to the current head position. Whatever the minimum distance required in the head movement, so it moves towards the, or basically it moves towards the request which is closest to the current head position. Like, it works on the basis of shortest job first, and it is easier than FCFS. So there are some advantage of SSTF, that it is easier in comparison of first come first serve. And but there is some drawback also in SSTF, that is may cause starvation. And in case of FCFS, drawback of FCFS is high seek time. So if any of the process is not in execution, or in any case it goes on the waiting state, then seek time also increases, and we can't reduce seek time, which is one of the important motive of DIC scheduling or CP scheduling, whatever we required. Now, in SSTF, basically, there is a numerical part of SSTF, how we solve the problem of shortest seek time first DIC scheduling algorithm. So, now in case of consider a disk queue which requests input output blocks and cylinders, there is also one queue which is given in the question, and the SSTF scheduling algorithm is used. The head is initially at the cylinder number 53, moving towards larger cylinder number on its servicing passes. So, there is a string which is given, and next is head. Head starts from 53, and now we calculate which is the minimum distance of 53. So, according to this string, there are two same distance, like 65 and 41, both are on the same distance in between, like 53 and 65, and for 53 to like 65 to 53 when head moves from initially, and 53 to 41 also consider the same distance, but what we required, what we considered. So we goes towards the second step. So now if we consider after 65, there is some another distance like 67, which is we can say that shortest or closest to the current head position. And in place of 41, there are some, if we consider 41, so it consider a larger distance in between, like 67 to 65. So we consider head movement towards head movement from 53 to 65. So when we needed to require what head movement, what is the required head, and when we got the both distances, we consider the second step of the same we are working with. Now, we move from 53 to 65, and after 65 to 67, and what will be the shortest distance of head movement towards 67, that is 41, and after that 41 to 14, and now 98, 122, 24, 183, that is solved according to the shortest seek time first or shortest job first. And then when we calculate the head movements incurred while servicing these requests, well, what will be the distance in between the head movements what we served. Now, first is 65 minus 53. Now, 67 minus 65 plus 67 minus 41. Now, 41 minus 14. Now, 98 minus 14, 122 minus 98. And 122 minus 124 minus 122 and 183 minus 124. These are some basically current movements, head movements of SSTF according to the we select that request according to the closest to the current head position. So, answer will be 236 cylinders. So, what cylinders we move in DIC scheduling algorithms with the help of SSTF? That is 236 cylinders. Now, next algorithm, scan scheduling disk algorithm. Now, in case of scan scheduling disk algorithm, this is scan scheduling disk algorithm is also known as elevator algorithm. So, what is elevator algorithm? Basically, DIC arms moves in one direction, servicing all the requests, and second what will be the second step, and reaching end, then reverses. So, how we solve this problem? Head starts from one end of the disk and move towards the other end, servicing all the requests in between. So, likewise, this is our string, and whatever we given, like 53 is the head starts from 53. So, first of all, we move one direction and servicing all the requests, and after that, we reach at the end point. This is the basic concept and step of scan DIC scheduling algorithms, in which we use the same process repeats. Scan algorithm is also called as elevator algorithm. Sometimes question may be asked like explain elevator algorithm. So what are the advantages? Basically there are some advantages of scan scheduling algorithm, that is better performance than SSTF. It's simply easy to understand and implement. It does not lead to starvation. There will be never be a starvation condition like FCFS. Now there are some limitations or disadvantages also, that is it causes long waiting time for cylinder just visited by the head, and it causes head to move till end of the disk even if there are no request to be serviced. Like we say that extra movement when jumping back, when it goes from one end and it goes for second end, so there will be some slightly delay for recently arrived request. Now these are some disadvantage or limitations of scan scheduling algorithm. Now we see the problem of scan scheduling algorithm. Consider a disk scheduling like input output blocks on cylinder like 98, 183, these string is given. Likewise, now the scan scheduling algorithm is used. The head initially at the cylinder number 53. So what we required in scan scheduling algorithm, basically disk arm moves in one direction and servicing all the requests. So head starts from 53 and it moving one direction and servicing all the requests which is given in the string, which is already given in the question, and after that it reaches one end and then reverses. It reaches one end and then reverse at the other end, or servicing another request which is given in this string. Now what will be the head movement? We directly write that 199 minus 53 and 199 minus 14. This will be the movement of scan scheduling algorithm. Now what will be the answer? That is 331. This is the answer of this problem. Now last is look disk scheduling algorithm. So in case of look disk scheduling algorithm, there is one overhead of finding the end request, and it causes long waiting time for the cylinder just visited by the head. Or we can say that similar to scan, but it stops at least request instead of going to disk and that's one end. So consider a problem, same string is given and the head starts from 53. So now we consider what are the head movements over in disk scheduling algorithms according to the problem. In disk scheduling algorithm, in case of look disk scheduling algorithm, it is said that similar to scan, but it stops at the last request, which is instead of going disk to back. So initially we started 53 given in the question already, like head move starts from 53 and we go from one last end, it not considered the last point. The last step is just one before of the last point, like 193 to 183, and after that it reverts to the one other last point, last movement. So it is already considered that we see that there are some save unnecessary movements. So with the help of this look disk scheduling algorithm, we basically saves unnecessary movements, which is already taken in the examples of earlier. Now in case of look scheduling algorithms, there are these two movements of head, and you check that the answer will be 299, which is very much closer or smaller than the scan scheduling algorithm. Now there are some advantages or limitations of look scheduling algorithm. So basically there is only one limitation, that is slightly delay in comparison of a scan scheduling algorithm. There are very much slightly delay for recently request received, whatever we required and whatever we consider from the previous algorithms, and when we talk about the advantages of look scheduling algorithm, basically with the help of look scheduling algorithms, we can save unnecessary movements. We have taken in the earlier, we have pursuing in the earlier dict scheduling algorithms, that is FCFS, SSTF, or scan algorithm. This is all for dict scheduling algorithm. Thank you so much.